and welcome to the Radiation Research Society's podcast here at the conference in Las Vegas, Nevada. I'm Allison, and I'm here with Merriline Satyamitra from AFRI in Bethesda, Maryland. Today we're going to be talking about radioprotectors. And Merriline, tell me a little bit more about the research that you're doing and how it benefits society.
Absolutely. I work in a Department of Defense sponsored laboratory, and our main focus is on finding a protector in the event of a large-scale nuclear disaster. We are primarily concerned in finding countermeasure that can be administered to our military personnel and our first responders in the eventuality of a nuclear explosion, an accident like Fukushima, which involves a large number of people. And this is a research that we've been engaged in at AFRI, which is a historical landmark in the United States. We've been doing this research for a while now. However, just recently we have partnered with the HHS, which tasked us with also finding countermeasures which can help people who have already been exposed to radiation. So we have a really nice marriage between the DoD and the HHS, and our laboratory is in the center of this really unique and very exciting research.
Yeah, that brings up a lot of questions. First of all, the agents that you're looking at, you said these radioprotectants are going to be administered hopefully to members of the military as well as first responders, but is that also something that would be given to people that have been exposed to the radiation from this nuclear fallout, so the actual public?
That is a uniquely important question, and that is the main purpose of our entire research, because the one thing we have noticed is a drug that can be given prior to radiation exposure will not perform as adequately when it is given after a nuclear event or a radiation exposure. For instance, the longer it takes for us to stage an intervention and administer the drug, the less effective it is. But we have come a long way, because as recently as 10 years ago, people were convinced that you could never find a mitigator. And when I say mitigator, I'm referring to those compounds that are administered after a nuclear event or after exposure to radiation. Whereas the agents that's given prior to radiation, where we plan it and we know we're entering a radiation field, those are referred to as protectors. Now, people were convinced when I started this research that we are never going to find a mitigator, that you only have the recourse of going into a medical facility if you get exposed to radiation. However, in the last few years, we've had a few successes. I wouldn't say we've been extremely successful, but there are candidates out there which shows a great deal of promise, and we are working to ensure that we find more and more components which can come into this pipeline, and hopefully we can do enough research and validate the results in such a way that we can take it to the FDA and say, look, here is an agent that can be used in the event of a nuclear fallout or to people who are exposed to radiation.
So once you find a drug that you think you want to test, what's the process that you use to vet this compound to see if it is efficable and safe to use with the public?
Absolutely. To answer that question, I had to refer you to a document that was published by the FDA, which is called the Animal Efficacy Rule. This is a rule in which in the events where it is completely unethical to test a drug for a particular indication in humans. For instance, nobody will approve a clinical trial where you will radiate healthy human beings, make them sick, and give them countermeasures. It's never going to be approved. It's never going to happen. In such an eventuality, how do you prove that your drug is effective? So the FDA came up with this law saying you validate the results in two models. One will be a small model, mammal, and one will be a large mammal model. And if you can demonstrate radioprotective and radio mitigatory efficacy in both the small mammal and the large mammal, then prove that in the healthy adults there is no side effects in the doses that you are testing, or you can combine it with patients undergoing radiation therapy,
Right.
and to show that it is having a beneficial effect. That is the pathway to get FDA approval.
Yeah, that's really interesting. So something that could come from your research also is a drug that could be taken by patients who are undergoing radiation therapy,
Exactly.
and so it kind of has
It has a dual benefit. But a lot of people are not convinced that the nuclear threat is real.
Right.
But the moment there is a scare like the recent Fukushima incident, people are banging down our door demanding to be given access to this drugs they think we are hoarding. Well, it's not really true, we're not hoarding any drugs.
Right.
But we are actively working towards identifying agents or subclass of agents that can be successful mitigators. And this is a really important mission, because once we have developed a drug and we put it out there that there is a drug in the event of a nuclear disaster, our public can go to sleep knowing full well that the government has their safety in hand.
Right. Now, you're not the only lab, say, in the world that's working on something like this, correct? There's other labs that are studying mitigators.
That is
for
absolutely
radiation,
correct.
Right. And even we saw here at the conference here in Las Vegas, there are lots of posters and even a debate over these radiation mitigators or radioprotectors. Do you think with the advent of personalized medicine or precision medicine that different drugs are going to work better on people based on their genetic makeup, based on their metabolism, and different things?
Status.
Yeah, their health status. Do you think that there isn't just going to be one
Magic bullet?
Yeah.
Absolutely, and this is something we are also exploring more as we are feeling more confident that there are mitigators and they will be effective to a large generic population. However, we do understand that there will be variation within that subgroup, so we are taking into factor age of our models. So currently we were using young adults, but we are also testing very young mice or very young primates, and we are also looking into the geriatric population to see are there differences in the efficacy of this drug that we've identified. Along with that mix comes other confounders, like what if they have a pre-existing condition which makes them more susceptible? Will this drug be effective, or will it actually be harmful? And again, we have a long way to go to answer all these different aspects of our studies. Something as simple as male versus female is still being hotly debated, and we are going back and looking at our data and looking at our those schedules that we're using, and we notice that there is a slight difference. So yes, the differences already exist, and with the advent of so much cutting edge technology, I don't see why we cannot tailor the countermeasures to the needs of each and every person. However, like I said, having a vision is wonderful, but taking the steps to achieve it will take a little longer.
Right.
Because the impossible always takes a little longer.
Of course. Well, delving more into like the molecular workings of these drugs that you're looking at, without going into too much detail, these radioprotectors, how do they work? Do they work to alleviate the effects of radiation as a person is being exposed to it? Or does it work, say, if someone has inhaled something that is radioactive, does it work to eliminate it from the body? So, or are there different types of drugs that you're looking at that do both of these things to attack not only the radiation that someone's receiving from the outside, but from the inside as well?
And you raise a very important point, which leads me to explain to people that every kind of radiation exposure is not the same. For instance, any radioactive material that is consumed or inhaled or enters the body, it is termed contamination, and the mode of injury for that particular indication is vastly different from what you would receive from external beam radiation. which means that the source is outside and you just hit with radiant energy.
Yes.
So understanding the differences in this mode of injury, it's very important to tailoring your radioprotectors. For instance, a contamination with the radioactive material will require completely different intervention than for a nuclear fallout. We know there's a highly hot or radioactive zone, and we're sending our first personnel there. For that purpose, a radioprotector is something which will probably enhance the antioxidant status of that personnel. It will increase their it'll prep the body to be highly immune responsive,
Yes.
and it will probably act upon your progenitor cells in your different tissues and prep it for an injurious situation. And if there is damage and death of these end cells, the progenitors are primed to go into multiplication to replace that depleted population.
Right.
So it's two completely different aspects, and again, it is highly important that we educate our public about what is the difference between contamination and going to a hospital and getting a CAT scan versus an external beam radiation or a nuclear event.
Right. Well, it's so interesting. I feel like I could talk to you about this subject a lot, and so maybe we'll get to have you back sometime to talk more about different radioprotectants and other things dealing with nuclear exposure or nuclear radiation exposure. But thank you so much for coming and speaking with us here at the Radiation Research Conference.
Thank you. It's
Thank
been a
you.
delight. Thank you
Yes.
so much.
All right.
It was so nice meeting you, Alison.
Thank you, and have a good day.